to graph this function. First, we start with a vertex, which is at -3, 1. Then we continue with the axis of symmetry, which is not part of the graph. We do not graph it as a solid line. Then we had -2 and -4. They have to be symmetric. Careful. So they have to be symmetric, equidistant, we say, same distance away from the axis of symmetry. We determine 0, -8, 4, 5, 6, 7, 8. And since we know that this is a symmetric graph, we will try to make it as symmetric as possible. And this is the graph of f of x, -x squared minus 6x minus 8. Now, if you ask me, what's all this? Other than, of course, the axis of symmetry, why is this so important? You'll see in a moment in word problems why I list them there. Any questions before we look at a word problem that involves quadratic functions? Any questions? Any questions? Okay, so let's move on to 73. A ball is thrown in the air from the top of a building. Its height in meters above ground as a function of time in seconds is given by this. How long does it take to reach maximum height? So this is problem 73 on page 359. We are given h of t, -4.9 t squared, plus 24t, and plus 8. So first of all, what type of function is it? Very good. It's a quadratic function. Does it have a max or a min? Awesome. So it has a max, quadratic, plus max. Excellent. We're asked to find how long it takes till it reaches the maximum. What time, how many seconds it needs to reach the maximum. What do I do? Which point will I have to determine that will give us the maximum and the time needed, the vertex? Excellent. So all I have to do, the whole thing reduces to finding the vertex. So find the vertex. How do I find the x-coordinate of the vertex? -b over 2a, which is negative. How much is b? Over 2 times a. So I find the time. So 24 divided by 9.8. I got 2.45 approximately seconds. I also want to determine the maximum. I know the maximum by this ball is reached in 2.45 of this 2 seconds and 0.45, and I would like to determine the height in feet. So how do I determine that? Very good. Age of 2.45 equals -4.9, 2.45 squared plus 24 times 2.45 plus 8. And I plug it in. Now let's see what we get. -4.9 multiplied by, I'm going to put the previous answer because I still have it, squared, and plus 24 times the previous answer, and plus 8. Should I show this with the software, what I'm doing? Please check my numbers. Questions for me? Questions? Did we have enough of quadratic functions? Can we move on to higher degree polynomial functions now? That's all they were asking. They were asking for the time and 37.39 feet. Okay, so let's continue with polynomial functions. 5.2. So you can say linear and quadratic are polynomial functions. They are. This one has degree 1, and this one has degree 2. But we're not talking about these functions here. These are done. We're talking about cubic, 4th degree, 5th degree, 6th degree, and so on and so forth. Basically, I put them in 2 different categories, and they are the same, very, very similar. Odd degree and even degree. If I understand how to graph a cubic function, I know the 5th degree, I know the 7th degree, I know any odd degree. If I understand how to graph the 4th degree function, I'll be able to graph the 6th, the 8th, the 10th. No discussion whatsoever. It's a long procedure, however. We had, in the quadratic function, we had 7 steps. Well, here we have more than 7 steps in graphing these polynomial functions. They require, the first example will take a while. Then the next one, examples will take a couple of minutes, but the first one will take a while. So, what is required, first of all? Number 1, domain. Number 2, x and y intercepts. Number 3, max min. However, we don't have the power calculus has, so this is only with TI. 4, symmetry. 5, degree. 6, and behavior. 7, multiplicities. 'What we don't know so far from all this list is what
is TI?
Texas Instruments, 84, calculator. Eight turns. So what we don't know so far from this domain, we know. X and Y intercepts we know. Max min we know how to determine. We'll go back. Symmetry, we've discussed that already. A degree we know. This is what we don't know. Multiplicities we don't know. We haven't talked about any of that. And maybe connected to terms. So these 3, I like to explain what they mean, and then we'll select problems and put everything together. Now, when we graphed x cubed, do you remember what I said? That the cross at the origin is not like this. So it's definitely different. Here, the solution appears once, multiplicity 1. But here, this solution, although it's the same, appears 3 times. If we have another situation that is even slower cross, like this, it doesn't mean that there are 3 solutions here. It only means that it crosses very, very slowly till it finally gets to cross. It gets closer and closer to the x-axis, but it takes a long time to cross, and then a long time to separate from it. And this is multiplicity 5. What does this mean? It means that the solution, this solution, let's say -3, x equals -3, is the only solution, the only x-intercept. But here, the same solution, x equals 0, has 3 appearances because it's x cubed equals 0, and x cubed has to have equals 0, has 3 solutions. But all of them are 0. That's why it has this appearance instead of this. This is a straight cross. This is a slow cross. And this is an even slower cross. So this one, let's say, let's say x equals 7. X equals 7 appears 5 times. That's why it takes so long time to this function to finally cross the x-axis. This is what we call multiplicities. I'm only talking about odd multiplicities here. Multiplicity 1, multiplicity 3, and multiplicity 5, and beyond. This is odd. This has nothing to do with the degree of the function. But now, let's talk about this situation. Different, right? What is the multiplicity here? And we've graphed the function like that, like x squared. Multiplicity 2. What do you think the multiplicity will be here, which is much wider than that? Exactly. So this is the even multiplicity. Why is this so important? Because I will know how the graph is turning. These are all turns. Turns on the x-axis. These are crosses. So odd multiplicity, T-plicity, crosses the x-axis. Even multiplicity does not. It turns. On the x-axis. Yes. So now let's talk about end behavior. We have not discussed end behavior before. Now we will. Very simple. So a linear function has 2 options, right? This is one option. Coming from -infinity going to good. What is the second option? Coming from +infinity going to negative. But it depends on the leading coefficient, right? The leading coefficient here is positive. The leading coefficient here is perfect. Awesome. What is the end behavior? -infinity to +infinity, or +infinity to -infinity. That's the end behavior. What about the quadratic function? What is the end behavior of a quadratic function with a positive leading coefficient? Back to, right, and with a negative leading coefficient? Same thing. All odd degree functions behave like this or like this. Or even ones like this or like this, depending on the leading coefficient. Mike?
If there were five terms, would you write 5 differently?
No. Terms are on the x-axis. End behavior is what happens to the function at infinity.
No.
No connection. The terms and the multiplicities are right here on the x-axis. End behavior means where the function goes when x goes to +infinity and when x goes to -infinity. No connection to the middle part of the graph. Okay, now this is not the exact order in which we are going to present. It doesn't matter, really. However, this must be the first. The rest, it's up to you. Now, let's start by looking at, you want to start with an odd degree or you want to start with an even degree? Okay, very good. I'm going to start with 58 on page 374, which is f of x equals -x cubed plus x squared plus 2x. Since you haven't chosen, you're going to tell me what degree is this? Good. Degree, yes, indeed. Very good. Degree 3. Let's start with the table. So degree 3. This implies that maximum possible number of max min is degree -1. That's always mandatory. 3 minus 1 is 2. So if you say degree 3, you cannot look for more than 2 max or min. Okay, and now let's get the table started. Please give me the domain of this function. Right, this is a polynomial function. No discussion there. Perfect. Okay, ready? I want to find the x-intercepts. How do I find the x-intercepts for this function or any function? Negative x cubed plus x squared plus 2x equals 0. I will definitely multiply by negative 1 and factor out x. So I get x cubed minus x squared minus 2x equals 0, and I have to factor out x. You told me the degree is 3. How many solutions we have to find? For sure. 3. And you will factor the x squared minus x minus 2. What will you get? Excellent. And you will get 3 solutions, and they are from the first factor, what do we get? Perfect. From the second factor we get, very good. And from the last one, what is the multiplicity of each x-intercept? How many times we found in this function x equals 0? How many times did we find x equals 2 in this function as a solution? And multiplicity 1 for both of them, and the last one also 1. So all these, when I put them in the table, negative 1, 0, and 2, 0, 0, 0, I write myself a note, cross. It's just a regular cross. Multiplicity is 1 for all of them. No solution, no x-intercept appears more than once. Let's go to the next step. The leading coefficient of this, make sure that it's in descending order, which it is. The leading coefficient is negative. It behaves like the linear function because it has degree 3. Degree 3 behaves like degree 1. Negative leading coefficient, is it this from negative infinity to positive infinity, or is it this from positive to negative? Very good. That's what I have to write. Positive infinity to negative infinity. Notice that I haven't even mentioned the y-intercept because when x is 0, y is 0. So let's go through the list and make sure we checked everything. Domain, yes. X and y-intercept, yes. Max, min in a minute. Symmetry we haven't discussed. Degree, yes. And behavior, yes. Multiplicity, yes. Terms, yes. Maximum 2. So the only thing we have to look at is symmetry, and we're done. We can. Which one? Which one?
Multiplicity is 1.
Yes, because x equals 0 appears only once. X equals 2 appears only once. X equals negative 1 appears only once.
So is that the multiplicity would be
1 for all of them. Yes, yes. Very good.
So how do you have the times of crosses?
Because if any odd multiplicity will definitely cross. That's the rule. If it's an odd multiplicity, it will cross. If it's an even multiplicity, it will turn.
But where are you?
At the x-intercept. In a moment, you'll see. Yes, Mike?
So say we found it was x equals 0, x equals negative 1, x equals negative 1. Would the multiplicity be 2?
Correct. For x equals negative 1, the multiplicity will be 2. Yes?
So how we get plus infinity or minus infinity?
From the fact that the leading coefficient is negative and it has degree 3. It behaves like the linear function. Is degree 1 or degree 3, they behave the same. Good. So let's look at symmetry. Final step here. So this is negative x to the third plus negative x squared plus 2 times negative x. We've done this before. This is negative x cubed with minus in front is x cubed. This is x squared, and this is negative 2x. Remember, we are asking ourselves 3 questions. Does this equal f of x? Does this equal the opposite of f of x, or none of the above? So that's for symmetry. For symmetry, we will always determine f of negative x. I just plug it in everywhere and I simplify. So is it odd, even, or none of the above? Remember, this was odd, and this was even. This has nothing to do with the degree. We're only checking whether the graph is symmetric with respect to the origin or with respect to the y-axis. Is this function identical with the original one? Is this identical with the original one? You said no. Excellent. If I multiply both sides here by -1, this will become positive, but this will become negative, and this will become negative. It's not. So the function is not symmetric. This is the only thing that does not fit in my table. Outside, not symmetric. Good. So now we are ready to graph this function. Ready? From left to right, we're only looking at the table. I don't care for anything else. Right now, I have all my information in the table. At -1, at 0, and at 2. So let's do this together. Ready? From positive infinity, the function has to cross at this point. No problem. It must have a turn. It must turn because it has to come cross again at the origin. No problem. It must turn again because it has to cross at 2, 0, going towards negative infinity. One more time, let's do this together. This is very important to understand the behavior here. It's coming from positive infinity, it crosses at -1, 0, it has to turn, it cannot have more than 2 turns because it crosses again at 0, 0, it has to turn because it comes back at 2, 0, crossing again. They're all regular crosses, no turns, no slow cross, nothing fancy. Now you can ask, do you know where this minimum is? I have no clue. Do you know where this maximum is? I have no clue. In algebra or calculus, we can't. And you can say, what if it's this? Very possible. I don't know. That's why we will find out. So let's punch in the graph in the graphing calculator and find out max min. And that's the end of the graph. That's it. So this is our function f of x. -x cubed plus x squared plus 2x. We can make the necessary adjustments in a minute. In a minute after we find the max min. So let's put it in the graphing calculator in y equals. What is going on? Okay, it's okay now. So in y equals, clear if you have anything else. So -x cubed. What am I doing? -x cubed plus x squared minus 2x, right? Was it? Yeah. Plus x squared plus 2x. Okay. X squared and plus 2x. Okay, I already have the graph. I'm just going to adjust the viewing window for my pleasure. I know there is no action more than -4 to 4. I'm not sure about the action for y. I'm not sure. I can cheat and look here a little bit, but I'm going to say -6 to 6 for now. And see what happens. And hit graph. So as expected, the graph is coming, as we knew, from positive infinity, crossing normally, and at -1, 0, it has to have a turn, crossing normally at 0, 0, another turn maximum crossing normally at 2, 0. So I see that the minimum is between 0 and 1. So I go to second and calc. I want a minimum, which is 3, and I want it between -1 and 0. And I don't want to guess. Give me the minimum. Okay, so the minimum is at -0.5, and the minimum value is -0.63, and that's a local minimum. So I will put it in my table. -0.5, -0.6, and now I want to determine the maximum, and I see it's between 1 and 2. I go to second and calc. Stop me if you have questions, please. With number 4, and it's between 0 and 2, and I don't want to guess. And the maximum is at 1.2, 2.1. You do not have to adjust the graph. All I would like you to write is that this point is negative 0.5 comma negative 0.6, and this point is at 1.2, 2.1. That's all I care about. You don't have to go back and adjust the graph. Now I would like to choose an even degree that has, this one did not have multiplicities. All of them were 1. But I like to choose one with a different situation, like, for example, 47 on page 374. Let's take a look. Not too difficult, right? There are a few things that we haven't discussed before, but I don't think that you find them too difficult. So 47 on page 374. And that's f of x equals x to the 4th minus 5x squared. Okay. Degree. Maximum possible number of turns. When we say maximum, yes, ma'am? It's 3. Which means, does the function have to turn 3 times? No. But it cannot turn more than 3. So remember x cubed. This is the graph of x cubed. What is its degree? Degree 3. How many turns maximum can it have? How many it has? No turn, no maximum.
This is just rise to line, so
It has no turn. By turn I mean this. Increasing, decreasing. That's a turn. But there's no turn in x cubed. X cubed is always increasing. Although it could have maximum 2, it has none. So the point I'm making is the number of possible turns doesn't have to be attained. It cannot have more than 2. That's all it says. So in this case, degree is 4, max possible number of turns 3. Possible number of turns, or max min. Perfect. So now I have f of x, which is x squared. And this is x squared minus 5. I factored it for what's coming next. Can anyone give us a domain of this function? The domain of this function is? Of course, all polynomial functions are friendly. And can anyone give us the end behavior? See, the first problem took us 10 minutes. This should take us a minute and a half, really. Yes, because it behaves like x squared. It has a positive leading coefficient. It's an even degree. It has to be positive infinite to positive infinite. Good. How many solutions? How many x-intercepts? Mandatory. 4 solutions of the equation f of x equals 0. So we have x squared minus 5 equals 0, and I want you to give me 4 solutions, even if some of them will be the same. But the square root, yes. X equals 0, x equals the square root of 5, and x equals negative the square root of 5. Very good. So what is the multiplicity of 0? 2. Which means a turn. What is the multiplicity for the square root of 5? 1. And the multiplicity for the negative square root of 5? 1. 2 plus 1 plus 1 has to equal the degree. 2 plus 1 plus 1. 4. This is a cross, and this is a cross, and this is a turn. So negative the square root of 5, 0, and the square root of 5, 0, 0, 0, cross, turn, cross. I only need the symmetry, and we're done. So f of negative x equals negative x to the fourth minus 5 negative x squared. Please tell me whether this function is odd, even, or none of the above. Negative x to the fourth is identical. Negative x squared is identical, so the function would be this x to the fourth minus 5x squared. What does this mean? Very good. It's an even function, so we have to make sure that the graph will be symmetric with respect to the y-axis. That's it. We don't need anything else. I don't care for any other information about my table. So the square root of 5 is a little bit more than 2. So I'm going to say somewhere here, negative and positive. And here's 0, 0. Ready? The graph is coming from positive infinity, crosses normally. It has to turn because it has to come back to 0, 0 where it turns. And it has to come back and turn again and go to infinity. One more time. From positive infinity, it has to turn somewhere because it has to turn, it comes back at 0, 0 where it has a turn, it has another turn here and crosses. It cannot have more than 3 turns. It will have 3 turns. So from positive infinity, turn. Now, I don't need to look at the rest of the table because I know that the function is symmetric with respect to the y-axis. Whatever I have here, I have to have a copy on the other side. So this is f of x, x to the fourth minus 5x squared. I don't know how low these two go, but they have to be at the same level. I only need to determine one of them. So let's go to y equals, clear whatever, and let's put in x to the fourth, and then minus 5x squared. And I go to window, and I'm just going to change this into negative 8, and that's good enough. It's crossing a little bit to the left of negative 2 and negative the square root of 5. Coming to a minimum, it has to turn at 0, 0 as we figured out because it has a multiplicity 2 there. It has to turn again and crossing and go into positive infinity. Now we are ready to determine the minimum between, let's say, between negative 2 and 0. So second in calc between negative, oops, I want the minimum. Between negative 2 and 0. Just give me the minimum. So that is negative 1.6, negative 6.25. 1.6, negative 6.25. Can anyone give us the other one? Exactly. 1.6, negative 6.25 has to be the same. And I will always put them in the table. Negative 6.25 and 1.6, negative 6.25. I couldn't hear you.
Does the term not, does it have the maximum or not?
This is also local minimum and the absolute minimum.
Yeah, but like the term, can it count as a maximum?
The term is always a max or a min. Always. A local max or a local min. Absolutely. Find the max. That is the minimum. You don't have to find the max. We already know this point. Yeah, that point is 0, 0. Any questions? Any questions? Any questions? Okay. I would like us to look at these. Let's discuss this. For the following exercises, determine the least possible degree of the polynomial function shown. How many terms? 2 terms. What is the minimum possible degree? 3. Can it be of degree 15? Yes, it can be. I don't know. but the minimum degree has to be 3. Would you agree? Okay, perfect. Positive leading coefficient or negative leading coefficient?
Positive.
Of course, because it's like the linear function with a positive slope. Okay, let's see the next one. So if it has one term, the degree has to be minimum 2. Okay, positive leading coefficient or negative? Negative. What about the last one? Careful. 1, 2, 3, 4. So degree 5. What is a positive leading coefficient or a negative leading coefficient? Negative. Perfect. Awesome. Not a big deal, is it? Initially, it appears to be something major, right? But it's not a big deal. Any questions about these functions? Any questions? Any questions? Yes, they require a little bit of work. I mean, don't expect that you go home and you're going to be able to finish this in 5 minutes, right? This homework. But do we understand what's happening here? So once you know how to graph an odd degree, you know all odd degrees. Once you know how to graph an even degree, you know everything about all even degrees. Okay, I still have 5 minutes left, so please, let's try and continue. Let's see where we are right now one more time. This is a check for you and also for check for me. So this was done, this was done, this was done, and we do have the supplement. We had several examples of this kind. So this is the supplement that I'm talking about, solving polynomial and rational inequalities. So let's work on one. I do not disagree with this method. I don't disagree with this method. I think it's longer and requires more steps than the method that I present. But it's up to you. If you prefer it, please use it. Okay, so let's take a look at just one example, and I promise after this one we stop. So please choose. Choose from here. What I would like to do, because that's going to be quick, is part B. And then we'll work on the other ones next time. So let's do part B, which is y cubed greater than or equal to 4y. Remember, these kind of inequalities, you cannot take square roots, you cannot take cube roots, you cannot perform operations that you would normally perform, maybe, in an equation. That's not allowed. So all I have to do first is move everything to one side, factor out y, get y squared minus 4, and of course continue factoring as much as I can, maximum possible. And then I'm going to use this table. Oops, of course it's y, not x. Yes, so this will be everything in the problem. Then y is the first factor, y minus 2 is the second factor, and y plus 2 is the third factor. And what we are really interested in is the product, y minus 2, y plus 2. We've done this at least 3 or 4 times. Let's do it again. So I need to identify for each of these a corresponding 0. Where is this 0, where is this 0, and where is this 0? And I have to put them in the correct ascending order. So what is the ascending order for those numbers then? Very good. -2 for this one, 0 for this one, and 2 for this one. So like we did before, we have to have a 0 in each row. Where will I have the 0 for y? Under? Of course, it makes sense. Where will I have the 0 for y minus 2? Very good. And where will I have the 0 for y plus 2? Perfect. What happens under these values for the product? A product will have to be 0. Why? Every time a factor in a product is 0, then, of course, the product will be 0. All these are linear functions with a positive leading coefficient. We know the sequence of signs. What is it? Of course. You don't have to plug in any number. If you would like to plug in numbers, please do so. On the first subinterval, I multiply 3 negatives. What is the sign of the outcome? In the middle, in the next subinterval, I multiply 2 negatives. What is the sign of the outcome? Perfect. In the next one, I have only 1 negative. Sign of the outcome. And in the last one, nothing. This will tell me what I pick. Which sign is greater than or equal to 0? And there is only one sign that is greater than or equal to 0. Positive. So y is in the interval. That's it.